Okay, welcome back. Um, there hasn't been a video in really long time, and so I want to do today a very complex and information stressed passage. If you take a look here around the passage, you'll see that there is a lot of words. There are 5 paragraphs here. This is written by Einstein on the truth about geometric ideas, basically physics in general. And you will see that such a straightforward topic can be rendered into this kind of writing, which requires you to think critically and think hard. So let's get into it. In your school days, most of you who read this book made acquaintance with the noble building of Euclid's geometry, and you remember, perhaps with more respect than love, the magnificent structure on the lofty staircase of which you were chased about for uncounted hours by conscientious teachers. By reason of your past experience, you would certainly regard everyone with disdain who should pronounce even the most out-of-the-way proposition of this science to be untrue. But perhaps this feeling of proud certainty would leave you immediately if someone were to ask you, "What then do you mean by the assertion that these propositions are true?" Let us proceed to give this question a little consideration. Geometry sets out from certain conceptions such as plane, point, and straight line, with which we are able to associate more or less definite ideas, and from certain simple propositions, axioms which, in virtue of these ideas, we are inclined to accept as true. Then, on the basis of a logical process, the justification of which we feel ourselves compelled to admit, all remaining propositions are shown to follow from these axioms, or in other words, they are proven. A proposition is then correct or true when it has been derived in the recognized manner of the axioms. The question of the truth of the individual geometrical propositions is thus reduced to one of the truth of the axioms. Now it has long been known that the last question is not only unanswerable by the methods of geometry, but that it is in itself entirely without meaning. We cannot ask whether it is true that one straight line goes through 2 points. We can only say that Euclidean geometry deals with things called straight lines, to each of which is ascribed the property of being uniquely determined by 2 points situated on it. The concept true does not tally with the assertions of pure geometry, because by the word true we are eventually in the habit of designating always the correspondence with the real object. Geometry, however, is not concerned with the relation of the ideas involved in it to objects of experience, but only with the logical connection of these ideas among themselves. It is not difficult to understand why, in spite of this, we feel constrained to call the propositions of geometry true. Geometrical ideas correspond to more or less exact objects in nature, and these last are undoubtedly the exclusive cause of the genesis of those ideas. Geometry ought to refrain from such a course in order to give its structure the largest possible logical unity. The practice, for example, of seeing in a distance 2 marked positions on a practically rigid body is something which is lodged deeply in our habit of thought. We are accustomed further to regard 3 points as being situated on a straight line if their apparent positions can be made to coincide for observation with one eye under suitable choice of our place of observation. If, in pursuance of our habit of thought, we now supplement the propositions of Euclidean geometry by the single proposition that 2 points on a practically rigid body always correspond to the same distance line interval, independently of any change in position to which we may subject the body, the propositions of Euclidean geometry then resolves themselves into propositions of the possible relative position of practically rigid bodies. Geometry has been supplemented in this way is then to be treated as a branch of physics. We can now legitimately ask to the truth of geometrical propositions interpreted in this way, since we are justified in asking whether these propositions are satisfied for those real things we have associated with the geometrical ideas. In less exact terms, we can express this by saying that the truth of a geometrical proposition in this sense, we understand its validity for a construction with ruler and compasses. Of course, the conviction of the truth of geometrical propositions in this sense is founded exclusively on rather incomplete experience, for that we shall assume the truth of geometrical propositions then at a later stage in the general theory of relativity. We shall see that this truth is limited, and we shall consider the extent of its limitation. Okay, very interesting passage, a lot of information. So 1 to 7, the author mentions Euclid's geometry and a lofty staircase primarily to describe a context, highlight the relationship, emphasize the importance, and relate his topic to a situation with which he believes most of his readers are familiar. Now, so here, in your school days, most of you who read this book made acquaintance with the noble building of Euclid's geometry and the lofty staircase, right? Now, if it is describing a context, then the passage would be talking about school, right? Because the context is the study of Euclid's geometry, and you get chased by conscientious teachers. It will not be a passage about physics, or else the context is not related to physics at all. B. Highlight a relationship between architecture. No, architecture is not part of this passage. Or emphasize the importance of diligence in the study of geometry. No, this is not about studying, right? So D is the correct answer. The author's use of the phrase "perhaps with more respect than love" is primarily meant to convey the sense of reverence, ambivalence, nostalgia, or formality. Now, first, it is not formal, right? Because it is not talking about teachers. Reverence means it's like respect, but it's more than respect. It's like a deep feeling of like worthiness. For example, if you revere someone, you think that they are a good person, and you want to model yourself after them, after their actions. And obviously the passage is not talking about that, so A and D is out. Now we have ambivalence or nostalgia. Now, nostalgia means remembering something in the past, particularly something happy, but here perhaps with more respect than love. It's not really happy, it's more kind of a forced way, it's respect, but it's not love. So it's B, because all other answers are not correct. But if you want evidence, then you can see that perhaps with more respect than love. So there is ambivalence here. Some may love geometry, some may study geometry because they are forced to, so in general it's ambivalence. Now, according to paragraph 3, the geometric concepts plane, point, and straight line stem from their truth, simplicity, similarity to entities, or cross-cultural acceptance. D is immediately out, B is also out, we have A and C. Now, the passage discusses the truth of geometric concepts and axioms. So obviously A is the opposite of what the passage is trying to do, right? And so A is wrong, we have C as the correct answer, because he says here, geometry sets out from certain concepts such as these, which you are able to associate with more or less definite ideas. Ideas means objects in real life in this context. Now, as used the phrase more or less. Geometrical ideas correspond to more or less exact objects in nature. Now, more or less, we immediately think about like approximation, but we need to look at other answers as well. Now, concretely, no. Quantitatively, could be. Unreliably, not correct. D, approximately. Now, between B and D, B is kind of like concrete and exact, while D is a more kind of general way. So the phrase more or less applies to D, approximately. According to the author, the Euclidean definition of a straight line is problematic because now it does not correspond to lived experience. It involves 2 points when it actually have 3. It does not sufficiently support the axioms, or it is logically connected to other geometric ideas. Now, first we need to look at something that we already know from the paragraph. Now, logically connected to other geometric ideas, where is that mentioned, right? Geometry, however, is not concerned with the relation of ideas involved in it to objects of experience, but only with the logical connection of these ideas among themselves. That does not relate to Euclidean definition of a straight line, right? Now, so D may be wrong, but it is not wrong yet. We need to find the straight line in the passage. We need to find what the author says about the straight line. Here, it is around this paragraph, if I remember it. Well, where is it though? I remember he said something about lines. This is about the plane points and straight lines. It's not difficult to call geometry true to refrain from such a coarse line. If in our pursuance of habit of thought we now supplement the prepositions, geometry has been supplemented a branch of physics, satisfy with those real things we are associated with the geometrical ideas. Oh, here it is. Now, if in pursuance of our habit of thought we now supplement the propositions of Euclidean geometry by the single proposition that 2 points on a practically rigid body always correspond to the same distance, line, interval, then geometry, we can now legitimately ask to the truth of geometrical propositions interpreted in this way, since we are justified in asking whether these propositions are satisfied for those real things we have associated with the geometrical ideas. So what he means in that convoluted sentence is that geometrical ideas are justified based on real objects. right? And the Euclidean definition of a straight line is problematic because it does not correspond to lived experience. Now, what about the other answers? It involves 2 points when it actually includes 3? No, it does not sufficiently support the axioms that come from it. They say that the axioms that come from the concepts are regarded as true but does not mention anything about the support, or it is logically connected to other geometric ideas. That's not a problem because that's the point of geometry, as he said. Right, now course mostly means, okay, so where is the course? Say we're accustomed. Wait a minute, where's the word course? Let's find the word course. Hang on. Okay. Geometry ought to refrain from such a course in order to give its structure the largest possible logical unity. So, is it class, practice, itinerary, okay, that's the word, direction. Now, course, in the simplest sense, it means the way or direction, but in this context, it does not mean direction. Direction here means in a more literary way, more like the way you do something, right? It's not the course of events, it's the direction of events, but it's the course of which you do something, how you do it. And how you do it, how you do something means practice, right? And B is the correct answer. These kinds of vocabulary questions, most of the time, the primary or the definition that you immediately think about is wrong, because when you say course, you think of a road, a way, and that is the main definition, right? But it is wrong. It is not direction, it is practice, because it is being used in a special context that requires you to understand the sentence and the word itself. Based on the passage, which choice best describes the relationship between geometry and physics? Geometry overlaps with physics. Geometry and physics are both important. Geometry is based in fiction. Geometry is measured using generalizations. Now, B is wrong, looks wrong, and it is irrelevant. C, geometry is based in fiction. Einstein said it is based on real objects, so C is wrong. It should be confirmed based on real objects, and C is wrong. Now D, geometry is measured using generalizations, or geometry overlaps with physics. First, you need to see if the passage mentions D or A. We see here the author mentions physics. Where is it here? Geometry, which has been supplemented in this way, is to be treated as a branch of physics. We can legitimately ask the truth of geometrical propositions. So that's the only time physics was mentioned. And about measuring generalizations, we see here. In less exact terms, we can express this by saying that the truth of a geometrical proposition. In this sense, we understand its validity for construction with a ruler and compasses. So obviously we need to measure it accurately, and so generalization doesn't fit. And experiments is not mentioned because he only says geometry as a branch of physics, and experiments aren't really mentioned, so A is correct. In the final paragraph, the author suggests that the truth of geometric propositions is challenged by, right here, the conviction of truth is founded exclusively on rather incomplete experience. So the problem with them is humans' limited ability to understand physical phenomena. It is not inability to confirm geometric truth by measurement. Be careful. Based on the passage, the author would likely agree with truth as, now, a concept that corresponds with lived experience, experimentally verified, practical setting, which a vast majority. Now, vast majority is not mentioned. The application of geometry in real life is not mentioned, so C and D is out. Now we have experience or experimentally verified. Now if we read in less exact terms, we can now legitimately ask as to the truth of geometrical propositions. Here, that's the phrase. Interpreted in this way, since we're justified in asking whether these propositions are satisfied for those real things we have associated with the geometrical ideas. So basically this means that the truth of these propositions based on whether they correspond to reality. Right? You may be fooled by this construction with a ruler and compasses. It does not mean that you measure it to confirm its existence, but rather you build it, right? Ruler and compasses is just a figurative language here. It's not the real deal. They're just there to trick you, right? And so it's the concept that corresponds with the lived experience. And here, the line that proves is the true the concept true does not tally with assertions of pure geometry, because the word true are eventually in the habit of designating the correspondent with a real object. There we go. And that is the last question. Of course, Einstein's writing is very hard to read, but if you read it carefully, you can answer every question correctly. See you next time. Thanks for watching.